Okay, here is your one and only chance to listen and learn how to do the spider problem. It's a very, very simple problem if you understand all the aspects of it. This wheel, there's a spider right here. He's 30 degrees below the x-axis on this 14 centimeter radius wheel. Here's a spider. This wheel is about to be rolled to the right 7.25 full rotations. So the entire wheel is moving to the right. Let's just say the center of the wheel, if it starts there, and I do 7.25 rotations, so 7.25 times this circumference is going to get the center of the wheel right there. This is not drawn to scale, it's just for illustration. Any questions on that? So if I find out the circumference of this wheel, multiply times 7.25, that's where the center of the bicycle is going to end up right here. Okay, so we need to find out that distance. That's our first task, and it's relatively simple. So 2 times pi times 14 times 7.25. Let's type that into the old calculator to figure it out. So 2 times pi times 14 times 7.25. So 637, let's go to 2 decimals. Nah, let's go to 2. 637.74. Okay? So that means this distance, the center to center, is 637.74 centimeters. But we have to take care of this distance right now, this plus or minus distance at the beginning of the problem, and then because it's 0.25 rotations, that's one more quarter turn to the right clockwise. That means the spider is going to add 90 degrees to this. So I know if he's 30 degrees below here, he's going to be at 30 degrees to the left here. So your knowledge of the unit circle is going to help you determine that this distance, this x distance here, and this x distance here to add or subtract off this basic number. And the last part of the problem is to figure out how high this spider is up from the ground, and that's going to be this y distance based on the coordinates of the unit circle again times the radius. Okay? So what is this x distance right here? Well, this x distance is the first coordinate. This looks like a 30, does it not? Isn't that a 30? This would be the other 30. So the x distance is which one, the left or the right? It's the left. So it's rad 3 over 2. So the coordinates of this point are rad 3 over 2 and negative 1/2, although we don't need the y coordinate. So rad 3 over 2, what you do with that is you multiply it times the radius. So the beginning plus or minus distance is rad 3 over 2 times 14, which is, Matthew, you watching this? 7 rad 3. Okay? So this distance right here, is that added or subtracted to 637? The spider had a head start, so we have to subtract this 7 rad 3 off of this distance. Now do the same kind of concept over here. What is the x coordinate? This is 30 down, so this looks like a 60. What are the coordinates? What's the cosine for a 60? Isn't it 1/2? That's right. What's 1/2 of 14? 7. So not only did he have a head start, we have to subtract off the 7 rad 3, but from the center of the circle he was even further back this way, another 7 centimeters. So we have to subtract that 7 off as well to find the final answer. I'll leave you guys to do that on your own. The last thing is how high up. What's this? The radius of the wheel is 14 centimeters. What's this y coordinate right there? It's a 60. So this is the y coordinate. It's rad 3 over 2, right? So we take the coordinates of this point right here are negative 1/2 and negative rad 3 over 2. 14 times negative rad 3 over 2 is negative 7 rad 3. Okay? And so our distance, if this whole thing is 14, We subtract that 7 rad 3, whatever that number is, that's how high he is up off the ground.